Okay. Well, without further ado, we'll get started. So again, the I put the link in the chat if anybody didn't get it. Just let me know if you guys have any questions at any point. Like, please feel free to interrupt me. This is like this isn't like professional or anything. This is super chill. So yeah, I'll just work through it and then hopefully we could learn some stuff together and then yeah, of course just ask questions if you have any. Okay. So today we're going to learn how to make some cool worksheets. I know like a super professional title, of course. Yeah, obviously not. But either way, we're going to go through. There are about four sections here. On the slides, you'll see that we don't have all the kind of subsections listed, but we'll reveal those as we go on. If you look in the handout, it has everything there. We'll be going over what LaTeX is, the basics of designing a worksheet using math mode, because that's probably the most important feature by far, is compared to Microsoft Word and Google Docs. Once you get over to a little bit of a learning curve on this, you'll realize it's just way better. It's very hard to go back to Microsoft Word equation editor after using this, honestly. And then we'll go over some like more, I guess, advanced stuff. I try to keep it limited because there is so much you can do, so much formatting, that honestly it would take, I don't know, days to go over this. But there's a lot you can do. And a lot of the stuff we don't go over, if you're curious about, you can always ask. Maybe I'll know. But also look online. There's places like Stack Overflow, tons of resources out there for LaTeX. And by the way, it's either said latex or LaTeX. They're synonymous. They're like the same thing. But it's always spelt like the word latex. Okay. So basically, LaTeX it's a programming language, but unlike any of the other programming languages you might have learned, if you are a computer science major or have just done programming before, LaTeX won't feel super familiar. It'll be a lot different because it's very oriented towards word editing, document building, paper building, anything like that. But also too, you can make slideshows. So this slideshow, for example, is made using LaTeX. Now, of course, it's not going to be as nice as a PowerPoint. I would say if you're going to do slideshows and you're not looking to throw a bunch of math equations in there, there's no benefit to using LaTeX. Honestly, you're going to have much better luck with something like Google Slides or PowerPoint, but you can use it for slideshows. And the formatting is the exact same. The really nice part is I basically made the slideshow and copy pasted all the code from that and put it into a document, and it kept pretty much the same format with some slight tweaks. So and furthermore, going on the programming language part, you won't see things like for loops or if else statements, anything like that. Like that's not the sort of programming you're going to be doing. It's just kind of a program where you throw your stuff in, you say, okay, maybe I want this paragraph on the left, or I want it centered or in the right, and it'll kind of just do that for you and format it in a programmatic way rather than you just kind of eyeballing it per se. And an important point in contrast to applications of Google Docs or Microsoft Word, a lot of what you do in LaTeX, you have to do yourself. So there aren't a lot of features in here where it's like, unless somebody made a library, which is something we'll go over later, there are a lot of features where you could just like click a button and it automatically formats it for you. You have to have that format in mind and build it up as you're programming your document. Okay. And then setting up a LaTeX environment is actually super simple. So there are two approaches that are the most common. First one is using online editor like Overleaf. Overleaf from, as far as I know, is probably the best one. The best one I have access to. The really nice thing about Overleaf is that it's cloud-based. So if you are programming on one computer, say in, I don't know, Los Angeles or something like that, and then you forgot your computer, but now you're in San Jose or somewhere like that, you can just log in online and your documents are right there. But another alternative is using a text editor or an IDE for those who've done computer science or programming, such as VS Code. And there are a lot more out there. Like I think there's one called LaTeX It, where it's literally just meant for latex or LaTeX. Um, but however, the downside of this is that unless you know how to use something like GitHub, you will not have offline access and or not, I shouldn't say you won't have like cloud-based access per se. You won't be able to access it across devices. It'll only be offline, which can be good. If you don't have internet connection, you can use it. You could type your documents, do whatever you need to. whereas Overleaf, you can't do something like that. But also, the other downside is that you need to know a lot more about programming if you're going to use an IDE than Overleaf. Overleaf does a lot of the like heavy lifting in the background, whereas an IDE you have to be a little bit more familiar with typing into the actual computer itself. Okay. So, for our purposes, we'll use Overleaf, of course. Going through the whole IDE route just takes way longer. We'd probably spend about the same amount of time just trying to figure that out as we would going through this presentation. So, in the chat, I did put the link for Overleaf. You could go there, you can create an account. It should be pretty simple. You can sign in with Google, I think, even Apple. I don't know if that's true or not, but there's also Microsoft. And then you'll navigate to the projects page. When you do create an account, so for example, if you guys can see my screen, what it will probably do is send you right into this page here. And so what you'll go to, and I just want to make sure, is everybody following along? I know I've been talking a lot. Cool, cool, cool. All right. So you go here, my camera's in the way, and you'll hit on new project right here. And then there are a lot of different options you can do here. So this is kind of what I was talking about with GitHub repo. You could, if you use GitHub, you could basically have your code stored online, bring it into Overleaf. We won't be doing anything like that. We'll just be doing a blank project. But there's also other options here if you are interested. There are some templates. So if you want to do like a resume, there's that. We'll do a blank project and then you'll just give it a name. So I'll just do sheet workshop and then it loads it up just like this. Okay. Then let me switch back to the slides really quick. Okay. So once you create that new project, you just hit the blank object, give it a title, you're good to go. Okay. I hit the wrong button there, not gonna lie. All right, and so now we're going to be taking a look at the Overleaf interface. So there are quite a bit of things here, admittedly, but only a few things are important. So the nice thing about having something like Overleaf is there are some things here that can make your life a little bit easier. And we'll get to kind of how to do all this later, but as you see here, it automatically puts in some code for you, and you just have to type in your text. But here, what you have right here, this is going to be your kind of your text editor right here, where you're actually going to put all your stuff. So if we change this, we'll say conclusion, so introduction. Um, it won't change anything yet. What we need to do is hit recompile. Once it recompiles, it'll change that. So now you see there's conclusion here. If you want to set it up so you can auto compile, you can turn that on here. The only issue is that if you have errors or you're just kind of I don't know, brain dumping, just putting stuff on the paper. Let's say, I don't know, maybe I misspelled section or something like that, like really badly. Um, Something like that. It will give you an error response. And it might render it weird. So sometimes Overleaf and specifically LaTeX is really good with being able to just render things, but it doesn't really know what to do. So obviously this isn't a thing. If it was a thing, I'd have been very surprised. Um, But that's an undefined control sequence. That just means this doesn't exist. So you can't do that. Okay. So let's see. That's the text editor. This is where it renders here on the right side. The left is going to be your file tree. So here, if you wanted to say you wanted to import something, you wanted to upload a file, you can 100% do that here. LaTeX is pretty flexible. You can import PDFs, JPEGs, PNGs, SVGs, you name it. There's probably something out there that you can put into here. All sorts of files. And then below that, you have the file outline. So you'll see as we add more sections, and then you could have sections the same name. I mean, obviously, it's just not good practice to have like four conclusions, but you'll see there in the file outline, it actually does add everything there. And this is something we'll go over a little bit later, but if you add a subsection, it will recognize that as well, and it'll put it under here. So this is the sort of stuff you get with Overleaf that over a text editor just gives you a little bit more of an edge. Okay, so let me remove all that so we don't actually have five conclusions And we'll just keep it as introduction here. Oh, and by the way, you can change the title here at any time. So if we wanted to say this is part two, we could totally do that like that. And then you could change your name. You could change the date. If we wanted to go to the future, we could do that. Or if we want to go to the past, we could do that. It doesn't really matter. And you don't even need this altogether. You can delete it and you're just fine. It just won't render it, of course. So if you want it rendered, oh well, it actually will. It'll just automatically put today's date, I guess. So you could either specify it, and I don't even think you need to put an actual date. Like you could put the word the, and it might actually, yeah, you could totally do that. So there's a lot of stuff you can play around. There's a lot of freedom, but at the cost of just need to know how it works. Okay, so that's an overview of the interface. Are there any questions on anything you see on the screen so far or anything else? All right, cool. So let's see. Okay, so now we're going to go to the second part, which is the basics of designing a worksheet. So this is the part we're all here for. This is probably the most dense part. But honestly, it's not conceptually difficult. It's just learning the syntax of the language. And once you get that, you can really do anything you want with that. Like this is pretty much, if you were to make a worksheet today, this is probably all you need. But there are oh, this in math mode, but there are cooler things you can do. Like this is not, you know, the limit. Okay. So one big thing in LaTeX, if you've worked with any other programming languages, these are typically, they might be called packages, but they're typically called libraries. It's basically code that either somebody else already made, and you can import it into your project. So for example, the graphics package, somebody made code so you can put an image and a caption for that image into your document, rather than you having to figure out how to actually do that, which makes things a lot easier rather than trying to figure out the formatting. It just kind of does it all for you. You really only need to include it. And that's just one example. A lot of these here are actually really useful. And if you have any questions about what each of these do, to be honest, I don't know what the L modern one does because I don't use it, but I think it's like a default one that um, the others depend on, as far as I recall. But the rest of them are pretty useful. Um, but yeah, packages in summary, just a library code that somebody else made that you're using that you can utilize for your project. And so to start off, we'll insert this code into the overleaf document. So what I'm going to do is I'm going to open up another project and copy the code from there because it's not going to let me, I don't think it'll let me highlight this right now. And this shouldn't change anything that we have. And also you can kind of just see like how this works. So we'll go here, go to here, and then we got all this. So I'm just gonna grab this, or sorry, this, and then we're gonna bring this back to the original document that we had just a minute ago. And that's always gonna go at the top. And so this top section, remove the ones that were there by default. This top section, this is called the preamble. And so I'll write that here, preamble. And if you want to comment, comments are a way to put something into the program, but have the compiler ignore it. So you can put whatever you like here, and the program won't care. But if we tried to do that here, it would probably it would just start typing. And since it's in the preamble before the document started, it's probably gonna, yeah, it's gonna throw an error and say something's wrong. It doesn't usually type it there. Okay. So this is the preamble. This is also part of the preamble. Anything pretty much before this begin document is considered the preamble. And once you begin the document, obviously that's when you can start typing and you're really putting stuff on the page. So is everybody able to get all this in? Hopefully you can copy and paste it. I don't know if you can from the slideshow, but I think from the handout you should be able to. If not, let me know. Um, and I can maybe put it somewhere else and we can figure that out. Okay. Gonna assume we're all good. Let me know in the chat or just get like raise your hand or anything if you're not, if you weren't able to um get all this and we'll move forward. But yeah, again, at any point if you have any questions or anything you get stuck on, please let me know. 100%. And you don't even have to follow along with this. Again, I am recording this. So if you guys want it later on just for reference, you could always just ask me and I'd be happy to send it over. Okay, so once we have all this on a document, then we can really get started. So I'll just kind of briefly touch on what each of these do. This document class, this is pretty much how your document is going to be set up. So one interesting thing we can do is we can remove this and put something called Beamer. That's going to be a slideshow. So if we do this, it should switch it over to a slideshow. And it'll look noticeably different. So yeah, now we have a slideshow. There are some errors because this doesn't work. This is intended for a paper. So if we swap this back out, we'll see that this will bring us right back to where we started with the paper. Um, and this specifies the default font size, which is going to be 10 in our case, and this is the size of paper. So there's letter paper, there's like A4, A3, all sorts of different sizes. You could always reference the documentation for more information, but typically, if you're going to be making worksheets, letter paper is the way what you want to go with. So these packages right here allow you to have more symbols. So at the end of the handout is a few pages. I didn't make those myself. I found those online. Honestly, I don't even know where I found them. But it pretty much has all the symbols that you would need to use for any purpose. Um, and so some of these symbols are a little bit more rare, so they weren't included by default in LaTeX, but these packages here add those in, so you can use them. Graphics, we already discussed, allows you to add a picture. This, I have no clue what this does, not gonna lie. This exfrac does, what this does is this allows more options for writing fractions. So if you've ever seen a fraction where maybe it looks like here, I can actually just demonstrate. So there's one called sfrac, for example, 3 and then 5, like that. And it should, maybe it won't, might not render it. Oh, it does. Okay. So yeah, right here you can see this is like this sort of inline fraction. So if you wanted to put some text like hello, my name is that or something like that, you can do that. It might throw errors because or not really throw errors. It might look weird because I put this below above the make title, which of course that's not typically what you want to do. But it's not going to stop you from doing that. It's just good practice to not do that. But you can do this instead if you did a regular fraction, for example, which again, we'll go over this later, it'll look a little bit different. So it's just a different style that you might want to use later on. So just some additional little tools that are pretty cool. And then we have this N, it's, I don't even know, enum item, I think is might you have, how might you say it? This one right here, we don't need this one, but when you create a list, for example, like a numbered list, like 1, 2, 3, it gives you more options, rather than you having to specify those options somewhere else in the document. So when you make the list, you could put an option next to it to say, oh, instead of bullets, I want to use triangles. Instead of squares, I want to use blue circles. Um, Pretty much you could put those options without having to write a whole separate line for that. Tabular array is a really cool one. It makes making tables a lot easier, a lot simpler, and a lot more modern. The T color box and theorems, those go together. That's something cool we'll check out later. Fancy HDR stands for fancy header. That's something we'll check out in a little bit. Microtype, we don't really need that too much today, but it's there. It's a cool little package. Name reference and system E, they allow you to reference other parts of the document more easily. In this hyperref right here, so depending on what you want to put in your worksheets, you might use this or you might not. But if you've ever done like a hyperlink in Google Docs, it's the equivalent of that. So say, for example, you wanted to put a link to Wikipedia. You could put the name Wikipedia and then the link so that instead of just plopping the whole link in your document, you put the word Wikipedia. A lot of times that's a really good thing to put to make things easier to read rather than just dropping like a whole 30 character link in there. And then this geometry package, this is what defines where you actually can put where the text actually goes. So for example, if we wanted to push the text really far down, it's going to recompile and then it should push everything downwards like that. So you can do that. I wouldn't suggest it. This is pretty much worked for me personally, but you are totally welcome to play around with it and throw in different numbers and so forth. So those are pretty much all the packages. And now that we've gone over that, everything else is a lot simpler. So the first thing we'll go over is we'll go over making a header and a footer. So the header is that little top part in the document. Sometimes there's a page number, sometimes there isn't. What you see here in the middle, this is typically what I put for my header. You are completely welcome to put whatever you'd like or whatever's requested of you to put there. Um, but yeah, you can stuff a lot of information in there. So the really nice thing about this package is that you can put stuff on the left and the right, which is sometimes a little bit tricky to do, especially tricky to format properly. This package handles that for you, and you can do it really easily. So if we want to actually develop the header, it's actually pretty simple. So what we have here is there are a couple extra lines. We have the begin and end document. Everything you want in your document, you have to put within this end in, or begin and end document. If you don't, again, it's going to throw errors, especially if you put it after end document. It's going to be like, yo, what are you doing? You see this page numbering here. This allows us to actually have Arabic page numbering. Sometimes, some designers will put Roman numerals for their page numbering. Sometimes, like in the beginning of the book, in the prelude or something like that, you'll see the Roman numerals, and then once the book actually begins, it'll be Arabic numerals. So we'll go put that there. Whoops, I did not mean to do that. There we go. Okay, so we'll throw that guy in there, and then Arabic. Okay. And then from then on, we can actually just make our header. So first of all, we're always going to want to put this guy. So what this does is this flushes out any of the other information in the header. It's not as important when you're first defining your header because obviously there's nothing there beforehand. But it's good practice to do it. For example, some people, some authors, some designers might want to have a header on even pages be one thing and odd pages be another thing. You can totally do that in LaTeX. And so doing this here just makes it more clean. Pretty much allows you to just alternate between the two a lot easier rather than having to rewrite things. So we put this guy, and then we're going to put fancy head, and then we're going to want to specify a side. So the nice thing is we could do L, we could do C, or we could do R. Of course, left or L corresponds to left, C corresponds to center, and R corresponds to right. So we do L here, and then I'm just going to copy exactly what's in the slides and hopefully type properly. Okay. And then let's see, College of the Canyons. Ignore my typing. Okay. So now that we have this, what it should do is we might need to, yeah, this should be fine. It should put in the header up there. Um, let's see, is it putting? Okay, let's see if we continue on. This, and so now we'll put one on the right side. We'll put professor, professor, and then we'll put fancy foot. And this allows us to actually put the footer in the page, which is that bottom part where you see that page number down there right now. That's going to be replaced by a footer. So let's see. So I want to make sure maybe I got the ordering wrong. But what we should see is a little header. So let me see something really quick. I'm going to show you guys how I usually make my worksheets. I use VS Code typically. Um, so let me see. Yeah, this should work fine. Let's see. Hmm. Okay. Oh, hmm. Normal. Let's see. See if I get rid of this. If that makes any difference. Doesn't look like it. We have the package here. We have this guy. Maybe this is throwing it off, but yeah, this usually should work fine. Worst case scenario, if it doesn't work fine, we'll circle back to this later because again, I don't want to take up too much time. Um, but this should realistically be working because this is the typical format for this. Um, but we'll troubleshoot later. I do apologize for this because if anybody notices if there might be a problem, let me know. Because maybe I accidentally wrote something wrong. I'm gonna remove this for now. Let's see. Yeah, because this should be okay, and sometimes ordering can be a little bit funky here. Let's see. Hmm. Okay. So, yeah, that's definitely interesting. Mm, I see what I did. Okay. I'm glad that this came up because okay, so with this package, we need to have this page style fancy. Otherwise, it's not going to use it. So there we go. And it should be, yeah, the page number is there on the right. So, okay. So I'm glad that happened because now that makes a lot more sense. So because this package kind of changes how the page renders itself, you do need to specify this page style here. And this is something that'll go before the document because this is, you can kind of think of it as setting the standard for when the document begins. Um, and you can actually swap this later on if there are like maybe on even pages. You don't want this fancy header at all. You can do that later on. But since we're going to be using it throughout, we're just going to keep this. So okay. Appreciate you guys' patience on that. I completely forgot about that part. And I'll probably add that to the handout after this. So hopefully nobody else gets confused. Um, but that's all there is to header and footer. It is a very straightforward thing. Um, and so, okay, yeah, okay. So now we'll go on to creating the table of contents. So this is probably, yeah, this is a poor joke on my part because I said this is the most advanced technique we might use today. Luckily for us, it's very simple. LaTeX makes it very, very easy. All you need to do is literally just put table of contents. So that's what we're going to do here. We're going to say in the introduction, maybe we want to put it here, table of contents, and it should just automatically render one for us. It's probably giving me the issue because I paused there for a second. And so if we just added a bunch of sections down here, you'll see that they'll render. It's kind of like the file outline on the left. And I'll put a subsection just so you can kind of see that too. Um, so yeah, this is the table of contents right here, by the way. This down here is the rendering from later on. And so you'll see, yeah, what it gives you is it gives you the page number of each one and it gives you the actual title number. Makes it very simple. For the most part, for worksheets, you probably won't use this, but if you do decide to compile all your worksheets into one document later on, this is a very helpful thing. It's a very cool thing, very easy. And there is some flexibility with the formatting. We won't go over that though. Okay. And then, okay, yeah, so now we're gonna just kind of fly through the rest of the sections until we get to math mode. And so next up, naturally, the next thing we want to do is to actually start writing a paragraph. A paragraph. I can spell. There we go. Okay. Writing a paragraph. Okay. So this part is the probably the easiest part besides the table of contents because literally all you need to do is type. Need to do is type and you're good to go. Okay. So basically you just write like that. Um So what you'll notice is I'm going to write another paragraph. I'm gonna write another paragraph. You'll see that there's this indent. And so also another thing is I want to show you the difference between if we don't do this extra space right here. If we don't do that, LaTeX is going to think that we just want to keep it on the same line. Because sometimes when we do this, say we're typing out a whole paragraph and we want to have it break in the text editor itself. So if we write this, this is all going to be on the same line. But in our text editor, it isn't because, well, we don't want it to start going over all the way to the right to the point where we can't see it. So we might hit return ourselves, or a text editor will do that for us. But right now we'll leave this. And so in order to get a line break, to put space in between two different sentences, you'll need this extra line here. Now, another technique you can do is this. This typically isn't as good of practice to do this, because it kind of forces formatting rather than just letting it naturally happen in the document. So I would really suggest doing this. And if you don't want this indent there on the left, you'll see there's that indent. All you have to do is put no indent to the left of it. And this backslash is always going to be how you start off a command in LaTeX. Um, Everything that comes immediately after the backslash with no space is going to be part of that command. So if I do this, it's going to throw an error. You have to put that space in between, but don't worry because the LaTeX will not put that space in there. So you'll see here, this is still perfectly aligned to the left. Okay. And then, yeah, that's pretty much 2.4. And then if we want to style our text, so sometimes, of course, it's important to actually bolden the text or put italics or anything else, make it a little bit larger, make it a little bit smaller. If you really want to emphasize something, there's a lot of freedom you can do with that. Everything that I put in the document or in the handout is really just kind of a fraction of what you can do with text. There's so many different formats, and at the very end of it, the other thing that I just kind of stole from online, again, I have no clue where it came from, um, that has a lot more options, but a lot of it seems to be oriented towards math mode, so that may or may not be helpful. So there's a total list of things you can do. So we can do italics like this. So it's going to be text, and then it's going to be some sort of abbreviation or shortening of whatever form you're trying to do. So usually IT stands for italics. If we wanted to do bold, you do BF, which stands for boldface text. And so these should all be on the same line. I'm going to make sure they're not, though. And then we have large, which is another really handy one when you just want a little bit larger of text. Again, what you do with this is completely up to you. There's a lot of freedom, and you can combine them, which is really cool. So you can do a bold, large font like this. So you can kind of nest them in between each other. And you'll notice these brackets here, or these curly brackets, that's going to be what you input into the command. So if you're familiar with programming, this is pretty much the equivalent of like a function. But even in math, you have f of x, x is in our case bold, and then it'll spit out something. So it'll spit out this larger bold font right here. So let me indicate that. And then we have tiny, which if you really want tiny text, you can do this, which is really cool actually, because there are a lot of cases where um, you'll find tiny text to be helpful. One particularly interesting case is that LaTeX actually doesn't, you need a whole package to have the degree symbol, so like degrees Fahrenheit. So sometimes you can use tiny text and get away with just putting an O there. Obviously it's not really good practice to do that, but you can do that if you're in a pinch. Um, so that's just one technique you use, or you could just find a different package for it online. But for some reason, I've rarely had success in doing that. Um, the fun one is huge. So this is literally, quite literally huge. Um, and of course, again, there's no limit to this. So, with document editors like Microsoft Word or Google Docs, you can specify the font size. You can do that in LaTeX. However, personally, I haven't used that very frequently, if at all. So I actually don't know off the top of my head how to do that one. And then we have small, and then we have script size, which kind of sits in between, I believe, small, and I think there's a medium option, script size, or regular option, which you don't have to specify, of course. Okay. So yeah, it's right in between small and tiny. So if you don't want something too tiny, but you don't want something too large, I guess, even though it's small, then you can do script size. And so that's pretty much, I don't want to say the limit what you could do text, but 99% of the time you're trying to style your text, it's gonna be one of those options. And then just to make sure, I know I've been talking a lot. If anybody has any questions, again, just feel free to raise your hand or tell me if I'm talking too much, because it's very likely that I am. So, I completely get it. But if not, we'll continue going on. Water. Okay, cool. Okay, sweet. All right, let's get going then. Okay, 2.6. So this is the one that's probably arguably the most important for worksheets. I'm gonna try and go a little bit quick because we have like 17 minutes. Again, I don't want to take up too much of your time. Um, 2.6 is creating lists. So lists are probably going to be the most important things. It's how you're going to number your questions. It's how you're going to create sub questions. And luckily for us, it's really easy. So what we're going to do is we're going to use a command called begin and then enumerate. So you'll see that a lot of things in LaTeX, when you want to kind of like cut off a section or make it a little bit different, begin is usually where you're going to want to go. Um, so here we'll just put, for example, actually, yeah, I'll get to that later, I think. Yeah, I'll end up getting to that later. Okay, sweet. So yeah, for now, what we'll do is this is a question. Please answer it. And then we have this item. So this just puts it in the list. This is really nice. Um, and then we'll go again and we'll say, okay, this time I'll have an item. This is the sentence. And then we'll put begin, enumerate again. And what this is going to do, we'll have to put an end as well. Everything in between this is going to go under this item. So now when we put another item, this is the question, we'll have this where it's going to have this part A. And you can change this. Again, I won't go over this because in most cases, usually this is like the standard. Um, but you can change whether this is an A or a Roman numeral. Like again, a lot of flexibility. And I would really urge you to go to like places like Stack Overflow or the documentation itself if you're more curious. But this will definitely get you by. And one small change I'm going to make right now is this. So that way, this text is not being affected. So the only thing you have to be careful about is that when you end it off like this, if you don't put another option for the size of your font, it'll kind of carry that through the rest of the document. So you can close it off with the brackets like that. And we can put the brackets back here again. But you don't necessarily need to because LaTeX has it has a lot of different ways of doing the same thing. And this is one thing you'll notice. So these two produce the exact same output, but they look a lot different. Okay. So this is creating a list, and you could, again, you could even go for another one if you want. You could literally pretty much do as many lists as you like, or sub lists, I should say. Like, and it can literally go on forever. Of course, it'll cycle through, probably go back to numbers or different sort of letter. Um, but there's really no limit to this. There probably is, but I mean, no limit that through most of your worksheets that you'll encounter. Okay. So the next big point, which I mentioned briefly earlier, is probably the most important part of LaTeX, is going to be using math mode. So LaTeX naturally has two different forms of math mode that are particularly useful in different scenarios. I won't describe those scenarios too much. I'll just kind of show you. the difference between the two. And then we'll go over some common math expressions and then writing chemical equations a little bit. I say a little bit because I haven't used it too much personally, so I don't know too much about it, but I have linked in both the document or the handout and the slideshow a link to the overleaf documentation, which is not only helpful for chemical equations, but helpful for a lot of other things you can do. Okay. So I'm not going to go through these slides too much. I'm just going to end up typing this out, and you'll kind of see um, the power in LaTeX. So if we exit out this list, we're going to want to enter math mode. So we'll do two types of math mode. We'll do this version and this version. Okay, so if we do this version, we'll do, say we want to do an integral, and then we'll say, okay, um, we want to start from A and we want to go to B. So what this underscore tells us, okay, start super or subscript. This power symbol or this caret right here is going to tell us we want an exponent or a superscript. And LaTeX already knows that for an integral, you're not going to be doing a subscript like, for example, I don't know if we did x sub a, it's going to look just a tad bit different because LaTeX already knows you're doing integral bounds. And then if we wanted to do sine, we'll do sine of, let's say, whoops, I meant to put these guys. Sine of x. And then if we want to put a square on there, we can. And then we'll do the same thing with cosine. So we'll just copy all this, close that guy off. And you'll notice here, I do put a backslash before sine and cosine. That's really good practice because otherwise it's going to look like this, which is okay. Most people will see that, okay, this is clearly sine, but it has this kind of, it looks a little bit more like variables. So say you had like sine of n, it's a little bit harder to read than this, for example. Not by a lot, but you can kind of subconsciously determine the difference between what's a function and what's a variable. But we're going to leave it as x, of course. And then the really nice thing is we can put some parentheses around this guy and just put dx here. And I believe there are options for differentials, but you can leave it like this, or if you want to put a little bit of space, backslash, comma, it'll just put a tiny space in between it. So this is pretty much how you'd write this function in LaTeX. A lot different than something like Microsoft Word, but pretty much you just have a lot more creativity with these sorts of things, and you can really do a lot more with it. And it's a lot simpler to use. Like once you get the syntax, it's a lot more natural. And if we put it in what we call display mode, then we're going to get something a little bit different. You'll notice it's a little bit bigger and it's automatically in the center, which is if you've ever read a textbook and you see equations that kind of break the paragraph and go in the center, they're likely using display mode. But if there's something in line, if you had a problem, say for example, let's say the bowling ball rolls at a speed of, and then you just want to put it in line, we'll put v of x is equal to 5x or something like that, then you would do that. But say the equation for this is, and then maybe you want to separate it like this. So this is just an example of the use case. Again, I don't want to go too much into it, but this is how you can pull this off and when you might use this. Um, and you could always, I believe there's an option, again, linked in the document where you could do display style. Um, but this is pretty much all you'll be need to use. But there are other options out there. To enter math mode? Yes, yes. So the dollar signs are used to enter math mode. Um, in some places, very rarely, it might be double dollar signs. But I don't believe Overleaf uses that. That honestly might get you into display mode. Yeah. So if you want to get into display mode, you could either do the backslash brackets like this. And you could put spaces in between. Again, LaTeX knows that you want to make it a little bit the code more readable. It won't actually throw spaces in there. Or you could use the double dollar sign. So there's some flexibility with it. Completely up to you which one you prefer. I think most people use this because it's a bit more modern. It might have a bit more features. But this, for our purposes, is sufficient. Um, so yeah, we have these two forms. And then that's just writing a math equation and seeing the difference between inline and display. Now, writing actual math equations other than this is pretty easy. From now on, I'm going to use display mode because personally I just like it a bit better. Um, you could do 5 plus 3 is equal to 17. You could do, let's see, 5 divided by 3 is equal to 6. Their writing it is really simple, pretty intuitive, nothing too different, but there are some special ones I want to go over. Of course, we already discussed the power one. So we have x to the a, for example. Maybe we have a sub n, for example, if you're writing a series. And then we have the integral, which we already went over. And then vectors. So vectors are probably going to be important for some of you guys, especially if you're doing like linear algebra or engineering classes. So you'll just do vec, and then we'll say a, and it will automatically put that arrow above. And if you want to do unit vector, you do hat instead of vec. So what's really important is that you put these brackets around, especially if you have like a vector with like two letters or three or four. And it'll just kind of center it, which is really nice. So this is where LaTeX handles a lot of that stuff. Is really flexible because it's a program. It's got algorithms running in the background. It's really flexible. And so those are some of the more important ones. A lot of the other ones you could find, there's stuff like square root as well. That's not something I listed in there. Square root 5, for example. Again, it's just going to extend until you exit out of here. And then it's going to put it outside the square root. So a lot of flexibility with this. And I already mentioned the whole thing with the sign functions. If there's a common function, such as maybe the determinant as well, I really suggest putting the backslash in front of it. So that way you can distinguish between what's a function and what's a variable, um, or a constant or anything like that. Basically, what's a number and what's not. Okay. So the last part of this section is writing chemical equations, which is pretty straightforward for the most part. Um, we've pretty much gone over everything we need to be able to write this. So I'm just going to copy the one from the paper, or the handout, and just kind of show you what it's like to write this. So writing this, we have two hydrogen H2, and then we have an oxygen, for example. And then the only thing that's going to be new, actually two things, is we're going to want to do right arrow. So there are a few options. We could do long right arrow. I know in chemical equations, they actually prefer to use a long right arrow. So we'll stick with that or just right arrow. Whichever one you prefer, whichever one's most useful. At least from what I've seen, in math, the regular right arrow is used, and in chemistry, the long right arrow is used. And there is place for you to be able to put text over it. I forget the actual command. I think it's X right arrow. So if you want to put, I don't know, H2O or something like that in your chemical equation, you can do that as well. And I'll leave that there, even though that makes no sense. I'll just put, I don't know, plus Q or something like that for heat. Um, I have no clue if that's actually correct or not. Okay. And then we'll just put the H2O, and then we want a fancy L. We don't want to do regular L because we're fancy. So we're going to put backslash ELL, and you get that fancy L that you'll sometimes see in textbooks. And if you want a little bit of space in between the states of matter and the actual chemicals, you could do that with a backslash comma, and it gives you just that little bit of breathing room so it doesn't feel all condensed. And there are more options. You could do like semicolon for more space. You could do slash quad. It'll give you a lot of space, but you probably don't want that much. The comma should do you well. Okay. And that is all for the chemical equations. Are there any other questions anybody has before we move on to the last section? All right. All right, cool. Okay. And so for the last section, we're just going to go over some kind of cooler things that aren't absolutely necessary, but are good to know because, again, it'll just kind of expand your toolkit a little bit more, get you more to work with. One cool thing is the definition or theorem box, which LaTeX makes really easy. So you'll need these two packages we mentioned earlier up here. And then what you'll also need to do is you'll need to go down here and basically type this guy out. So new TCB, and then we're going to want to put theorem, if I could spell that correctly. There we go. I did not spell that correctly. Okay. And then we're going to want to put something called auto counter. So wow, that was a bad mistype. Okay. What we're going to want to do is we're going to put out auto counter because that allows us when we have multiple definitions one after another, it's going to say definition one, definition two, theorem three, something you would see in a textbook. So it's not necessary, but it is a nice feature to have because then you could reference it later on using numbers, and that's just generally a lot easier to do than writing out a whole definition name. Um, and so then we'll just call it my def. So we'll just call it my definition or my def in this case, and this is how we'll refer to it later. And then we'll say it's going to start off with definition. So we could put theorem as well, just to kind of keep it different from the worksheet. So you can kind of see that difference. For some reason, there's this percent sign. I don't think we need it. I'm going to keep it there. Um, yeah, I don't know why I have that, but I do. I think it might have just been from copying. So then I'm going to continue this and say column back. So the back of the column is going to be this color here. And again, this is something you can kind of play around with, which is really cool. Again, a lot of flexibility. Actually, I think I did five. Yeah, I did five here. And then we have the column frame, which is going to be this here, 35, and then the color black again. And then we'll do the font title. And this will give us a format for the title. This BF series is going to be the boldface series. So when we did the text BF, where was it? Right here. It's the same thing, basically. And then we're just going to say def here. Okay. And so this is all the formatting we need. And now, thanks to this package, we could just basically begin using this. So down here, what I'm going to put is begin my def, and then we'll say, oops, this is a cool box. And then let's see, we have example here. Okay, sweet. And so right now I'm actually referring to the little handout because I always forget how to write this. So that is something that you'll probably do often is refer to your like older work. Um, and then just kind of reuse it or modify it in a way. Okay, so now that we have this, we should see once it compiles. Oh yeah, this can happen sometimes. There'll be like a server error. Um, but just no worries. You could always just hit recompile again and it should go ahead. Yeah. And then now you have this box. So this honestly isn't like super useful. It's just kind of cool to know and sometimes cool to write. If you put this on your worksheet, people will be like, "Whoa, what the heck? You had a definition box?" Um, which is kind of fun sometimes. But it's also cool. Makes you feel like a textbook writer or something like that. It might be useful in some cases. Who knows? Okay. And so sorry if I'm kind of going fast again. I'm really trying to keep this short. And not take up too much of you guys' time. Thank you for all showing up, by the way. Um, and the last thing we'll go through is creating mini pages. So mini pages are kind of like a little section you could have in your document where you set your own rules in that little section. You could divide it up in certain ways. It's pretty much a document inside of a document, um, which is really useful when you maybe want to put an image on the left, some text on the right, or vice versa, which is personally what I've done before. And that's what we'll kind of show here. And so to do that, we don't have to import any packages. It's something that's natively in LaTeX, which is really nice. So we begin the mini page here. And the nice thing about Overleaf is it auto completes some stuff. So every time you put the begin, it puts the end as well. Um, which is really nice. And this is also another issue with auto compile is sometimes you'll just be in the middle typing something and then it'll just throw a bunch of errors because you haven't put anything in yet. Okay. And then we're going to want to specify how wide we want this mini page to be. So if we want something on the left, maybe we'll do this. We'll do line width, or sorry, text width. You can do line width or text width. Either one usually produces the same thing, just depending on how you formatted your document. So it's good to always play around with that before, and just see what you like. And we're going to do something called ragged right. So it's going to push everything within this frame to the right pretty much. Um, which is kind of doesn't make sense, admittedly, that if you're putting something on the left, you're putting right. But I believe if I understand correctly from the documentation, basically what you're doing is you're taking everything that's in the mini page and putting it to the right, not the actual mini page itself. And then we're going to want to put some text here. So I'm going to do this so this actually shows up there. And that's it. We're going to do one more thing called hfill. What that's going to do is it's going to fill the space of the line that's not taken up. So basically, we have something on the left. We're going to take up space until we encounter that thing on the right. That way we could have something on the left, something on the right without them being squished together or centered or anything like that. And we'll begin another one. This time we'll do three because if we did four, it might overflow because everything in LaTeX has a thing called a padding. Pretty much the padding is area that maybe it's about like 5 pixels or so, so that if you have text right there in the top left corner, it's not touching the box itself. There's a little bit of room in between it. So that's why we do the zero point 0.3. And that's why we have to do this H fill because this kind of that padding, that distance in between is a little dependent on how you format your document, what you have around it, what you have inside the mini page. So it's just easier to kind of limit or restrict the amount of space you have just by a small bit and then let the program fill in the rest of the gaps. And so here what we'll do is now we can do the same thing we did before. Maybe we want to put image here. And so when I'm putting these backslashes, this basically escapes the curly bracket here because otherwise it actually just won't show up in the text. And so you'll see this is what happens here. And you'll see that this guy doesn't actually do anything. It's just used to separate portions of text. It can help with readability. And then if we wanted to import an image, I don't have any images uploaded right now. It is really simple. All we have to do is let's delete this. We'll say include graphics. What it's going to ask for is an option for the width. And this one will do line width. The nice thing is this line width is going to be the line width of the mini page, not the entire document. So it's not going to take up, 100% of the document, only really 30% or at least the size of the mini page. And then we'll put the file name here. So this is going to be our file name. Um, what I'm going to do is I'm going to leave it blank for now because if I put file name, it's going to throw an error. We might be able to comment it out. I don't know how to do an inline comment because I've never really had to do one. Uh, but that's pretty much it. That has been a lot of talking. So please, if there are any questions, let me know. I'd be happy to answer them while I'm here. If you have any that come up later, let me know as well. Happy to answer later. This stuff is super fun. Like once you get into it and you start just formatting your own documents, once you create that template, you can pretty much do whatever you like with it. But yeah, also I'd be happy to share kind of the source code for like a couple maybe of the worksheets I've had before. Um, if anybody would find that helpful. But yeah, I really appreciate you guys taking the time to listen to me yap at you for pretty much an hour. But yeah, I'll leave about a minute or two for questions. Do we have to download an extension? Will you be posting this video anywhere? Yes. So for Visual Studio Code, I can probably show that just since my screen is up. Let's see. Yeah. So if we want to use in Visual Studio Code, we'll need to download an extension. It should just called LaTeX. And let's see, which one do I have? I think, is it this one? Yeah, LaTeX Workshop. So we'll use this one. And then this, the actual language support. And you might need to download a compiler online. I'm forgetting that step. Um, but this pretty much handles it all for you. So, you'll need those two at least, and then you might need to download compiler online. But honestly, that last part, the download a compiler, I blank because it's been a while since I've done it. But I do know once you have those extensions, then you're pretty much set. Hopefully that helps. Oh, yes, and then the video as well. So I'll probably be posting the video on like just my personal YouTube channel, and then I can send the link afterwards for sure. I just want to make sure I like recorded the audio and everything because I've never recorded video on Zoom before, I'm not gonna lie. So I'll check that and then I'll upload it and then I'll share that with you guys. I really appreciate you guys all coming to listen again to me yapping for like a whole hour. I hope you learned something. Again, I'm always here for questions. I really want to help you guys out. I know that running AEWs can be a lot, and by making cool worksheets, I know you'll have some cool AEWs. If there's anything I can do, you help. You have a YouTube channel? I do. Well, I do have a YouTube channel, but not like it's not like an official one. It's just more like just kind of like I just dump like random stuff there. But maybe I'll start posting. Who knows? But yeah, I'd I love to help you all out. So just please keep me in the loop if you have any questions. But all right. Well, that's been a lot of talking again. Thank you guys. If you have any questions again, please reach out. I will Oh wait, Jesse, did you want to say something?
No, I just want to say thank you, man. I
Oh
appreciate
yeah.
this.
Yeah, no problem, man. Hopefully you learned something, bro. Hopefully.
Yeah, thanks.
Alrighty. Helpful. Of course, guys. I'm just glad to help. So, okay. Well, without further ado, I guess I'll end off the little workshop here. Please, again, I know I've said it like probably 100 times. Feel free to send any questions my way. I'm here for you guys 100%. And have a great rest of your day, everybody. I'll see you when I see you.
Thank you, Cameron.
Of course, man. Of course.
And
Is
also,
Yeah, of course. All right. Bye-bye, guys.
all right, good luck on at slow.
Yeah, man. Thank you.